Hello everyone, welcome back. In this video, I will be discussing perhaps the indisputably most annoying aspect of owning and building a laser cutter, that is, aligning the mirrors. On a typical laser cutter, there are three mirrors that redirect the laser beam from the laser tube to the laser head. When aligning the mirrors, it is important to align each mirror progressively, beginning from the mirror closest to the laser tube. This ensures that you only align each mirror once, as each preceding mirror will affect alignment of all subsequent mirrors. The method of aligning mirrors on a laser cutter is pretty standard and has been discussed in various YouTube tutorials, but through this video, I hope to provide more in-depth visualization on how this process works. First, position the subsequent mirror and corresponding axis as close to the mirror being aligned as possible, usually at either a software or hardware end stop. Then, stick a piece of masking tape on the mirror. Ideally, the tape should produce a distinct mark when pulsed by the laser. However, doing so produces a lot of smoke and soot which would contaminate the mirrors. I found that placing a piece of aluminum tape before the masking tape helped prevent any soot from contacting the mirror, reducing the need for cleaning of the mirrors after alignment, which may have messed up the alignment. Pulse the laser for a very short period to get a small but noticeable spot on the tape. From experience, a 10 millisecond full power pulse works great. A short pulse also prevents any serious injury from happening should the mirrors be so misaligned to the point that the laser is redirected out of the machine and onto you or any surrounding objects. Then jog or manually move the axis with the subsequent mirror to the furthest position from the previous mirror. Repeat the process of pulsing the laser, observing the position of the new spot. If the new spot is higher than the original spot, it means that the mirror is angled too high up, and vice versa. If the new spot is to the right of the original spot, it means that the mirror is aligned too much to the right, and vice versa as well. The way to visualize this is to imagine that you are moving down a triangle. This side is the misaligned path of the laser beam, while this side is the path of the beam if it were perfectly aligned. When you pulse the laser at the point closest to the mirror, the spot you get on the tape is a point along the perfectly aligned path. However, assuming that the mirror is misaligned, as you move further away from the mirror, the spot will move away from the original correct spot. One way to determine which spot is old and which would be new is to observe the relative intensity of the spot, as the spot produced further away from the mirror will be lighter due to laser attenuation. However, when the spots are very close, it is best to observe the tape as the laser is pulsed to see slight variations in the spots produced. Thus, the aim of the game is to move this new spot to coincide with the old spot, which will mean that the laser will hit the next mirror at the same spot regardless of its position. Now that we know how laser alignment works, the process of aligning the mirrors is actually quite simple. On each mirror there are 3 screws, each for one of the 3 corners. Working the screw pushes that corresponding corner out, causing the mirror to shift the other way. For instance, working this bottom screw will cause the mirror to rotate upwards, and hence shift the spot upwards. However, as this screw is also located on the left-hand side, working it will also cause the mirror to rotate to the right, thereby causing the spot to move rightwards as well. Before I begin aligning the mirrors, I reset the screws on each mirror by twisting them counterclockwise several turns and then clockwise till I physically feel some resistance. This ensures that the screws are just touching the mirror plate. Repeating this for all screws ensures that the mirror plate sits flush against the holder. I typically start the alignment process by observing which direction is in most need of alignment and adjust for that direction first. I usually adjust the screws and then repulse the laser at the maximum point again to see how much the spot has moved on. However, bear in mind that depending on your setup, adjusting the screws may change the position of the first spot, and you will need to redo the entire process of jogging and then pulsing again to validate this alignment. The laser head is trickier to align as the alignment shifts to the vertical direction. However, a very important step at this stage is to ensure that the laser enters the laser head at the center of the mirror mount. This is because there is a lens in the laser head which focuses the laser beam, and from my experience, the laser has to hit the lens about center in order for the lens to focus it vertically downwards. You can check that this is true by placing a piece of masking tape over the entrance to the laser head and lightly depressing the tape into the cavity. This creates an outline of the opening on the tape and allows you to see the relative position of the spot when it hits. If the spot is way off center but the previous mirror is aligned, you may have to tweak your design to shift the entire head to ensure that the laser hits the center of the opening. Although there are adjustment screws on the laser head, I found that the laser head was often best left untouched, as assuming that the head is mounted vertically, there is often little to no adjustment needed. To test the accuracy of the alignment, I placed a piece of clear tape under the tip of the laser head and pulsed the laser. If everything is aligned, there should be a small clean hole right through the center of the smudge circle made by the tip. If the hole is off-center, repeat the process of adjustment of the screws just like the previous two mirrors, just and do it on the laser head. However, if there's no hole made, chances are that the laser has completely missed the exit of the laser head and is hitting the walls of the nozzle. To check that this is true, lower your Z-axis, remove the nozzle and place a piece of masking tape flat against the bottom of the opening. Then depress the tape to create a mark, like previously before pulsing the laser to get an estimate of the position of the laser beam and adjust the adjustment screws accordingly to shift it to the center. It is worth noting that you should check that the laser beam hits the entrance to the laser head in the center before attempting these steps. If there is insufficient Z clearance to depress the tape, use a pencil to create an outline of the opening and deduce the position of the laser beam from there. After everything is done, test once more that the alignment for all axes is correct. You can do this by placing a piece of tape on the laser head entrance opening and pulsing the laser at both the home position and the position diagonally opposite that. If all alignment is correct, you should see little to no deviation in the position of the spot. Check once more that the laser is coming centered through the laser head tip by performing the clear tape test. And there you have it, folks, a quick and dirty guide on how to align your laser cutter mirrors. Be sure to routinely check the alignment every now and then, especially if you are like me and have a very large machine, as sometimes vibrations may cause the alignment screws to shift over time. With that, I would like to thank you all for watching, and I will see you in the next video. Goodbye.